Hello and welcome to Matt Specimen Paper 2, questions F to J, the last 5 questions. So these tend to be a bit more interesting, don't they? Let's face it. Questions A to E tend, not always, because I've seen a question B before where I'm like, that's really got me thinking. But most of the time A to E are pretty gentle and F to J are where it steps up a notch. So let's see if this catches us out. It is a specimen paper, remember, and they are, I'll be honest with you, slightly easier. Okay, the turning point of the parabola, so we need the turning point here, and we want it to be closest to the origin. Wow. So it'd be nice if we could write down the turning point, which we can do if we complete the square or differentiate, whatever you prefer to do. You can do either way. Half the middle term, square it, minus a squared plus 1. Hopefully you agree with me that the completed square form should look like that, because you're going to get x squared minus 2ax plus a squared minus a squared plus 1. So you're going to get exactly this. So where is the turning point? Well, the turning point will be when x is a, and when x is a, y would be 1 minus a squared. So that's going to be our turning point. Yeah. Now, when is this closest to the origin? It's closest to the origin, I guess, when we... now, let me think. How are we going to get that closest to the origin? Well, let's work out the distance from 0, 0 to a 1 minus a squared, and then let's minimize that distance. Yeah, that's what I'm thinking. It's good. Let's actually find it, because they're suggesting a value here. I suppose what I could do now actually is I could just plug these values in and see what turns up, because I'll be able to. It depends actually, yeah, because all of these values are possible values for a there, and now I could just kind of plug them all in and see which one's closest to the origin. That's one way of doing it, but the more sort of like professional way of doing it is to work out the distance. I'm not going to work out the distance. I'm going to work out the distance squared just to make the differentiation slightly easier. Distance squared is going to be equal to a squared plus 1 minus a squared squared. Yeah, and I could obviously square that out. This is not the quickest way of doing this. You should have probably just checked which one is, after plugging in those a values into here, you could just see which one's closest. But I'm doing it like this now, and this is like the more professional way of doing it. So the square of the distance is equal to a to the 4 minus a squared plus 1. And so if I differentiate this, dd squared by dA, I'm going to have 4a cubed minus 2a, and I'm going to set it equal to 0 to find the value of a, which minimises that distance. And so 2a cubed minus a, let's take out the 2a actually. 2a times 2a squared minus 1. Yeah, that gives a equals 0, or a equals square root of 1 over 2 plus or minus. Yeah, now we've now got to decide which one of these two it is, which is why we should have just plugged it in. One of this is going to give us a maximum distance from the origin, and one of them is going to give us a minimum distance, closest distance to the origin. Now if you plug in 0, you get 0, 1. Yeah, that's a distance of 1 from the origin. But if you plug in root 1 over root 2, you get 1 over root 2 here, and then you're going to get 1 minus a half, which is a half, and that's a distance of a half plus a quarter square rooted, and so that's going to be, as it's 3/4 square rooted, that's going to be closer than 1, because the square root of 3/4 is smaller than 1, and so the answer is D. Yeah, I did it kind of like in a faffy way there, but well, not a faffy way, because that is a proper way of doing something like that, but not necessarily the quickest. But there we go. I'm like I say, I'm doing these questions genuinely live because I left the my answers at work. Okay, 4-digit number is such that any 2 consecutive digits make a multiple of 13. Right, let's check we understand that. They're 2 consecutive digits. Is that a multiple of 13? Yes, it is. These are 2 consecutive digits. Is that a multiple of 13? Yeah, it is. These are 2 consecutive digits. Is it a multiple of 13? Yes. So that's what they're talking about. Okay, another number n has the same property, and it begins with a 9. Yeah? Well, straight away I must know the next number, because what do I need to times 13 by to get something in the 90s? What is 7 times 13? 91. So the next number must be a 1, which means the next number must be a 3. which means the next number must be a 9, which means the next number must be a 1, next number must be a 3, next number must be a 9, dot, dot, dot. Okay, so it's 100 digits long. I guess it's going to finish, well, we're going to have 913, 913, 913. So can you see that if you were doing like, 33, 66, 99, 99 is actually a multiple of 3, so it needs to be one after a multiple of 3, so it needs to finish in a 9. In other words, when you've got to your 99th digit, you'll be on 913. That'll be the 99th. Yeah, because that's a multiple of 3, and hence the next one must be a 9. So I think it's D. So far we've got D and D. Okay, what about this one? Okay, this equation has how many solutions basically? It has an odd number of real solutions, 20 real solutions, no real solutions, or x equals 2 as a solution. Well, it never hurts to rule things out here. If I plug in 2, I get 4 minus 2, so I get negative 2 on that side, and nothing to the power of 10 ever equals negative 2, so it can't be that, can it? Okay. Let's try actually sketching this now, because it's just occurred to me, this is a power of 10, and this is a quadratic which might lie completely below the x-axis. In other words, this is always less than 0. Like, it just suddenly occurred to me, if it's got no real solutions, that might be what's going on here, and I bet that's what is going on. Let's have a look. You get a feel for the kind of questions they ask after a while, don't you? Plus 2x minus 2. Let's actually find a turning point by making that x squared plus 2x, sorry, minus 2x, oops. Plus 2, yeah, and now just complete the square on that. X minus 1 all squared, minus 1 plus 2, which is plus 1. Okay, so the turning point is at 1, right, okay, be careful. The turning point is at when x is 1, y is minus 1, because you've got to apply that minus, not into that bracket, but definitely to that plus 1 there. We can now see the turning point occurs at 1 minus 1. And it's an upside down quadratic, yeah? And it goes through actually here at minus 2 as well. Sorry about my terrible diagram. But can you see how this couldn't have any solutions, yeah? Because the y coordinate is always a negative value. And yet this is something to the power of 10. And so it's B, no real solutions. Okay, next one. Observe that 2 cubed is 8, 2 to the 5 is 32, 3 squared is 9, and 3 cubed is 27. From these facts, we can deduce that log base 2 of 3 is between that and... Ooh, this sounds a little bit more interesting. Good. This looks harder. Okay, so straight away, I'm going to take logs both sides of that, and I'm going to see that log 3 log 2 equals log 8. Yeah? Does that help me? Or maybe I want to divide some of these. Let me just have a little look. This is the first one I've come to where I'm genuinely like, ooh, I'm not entirely certain how I will do this. I suppose what I could do, like, I don't know, like, it's risky. Between 2 and 3. Oh, are these all mutually exclusive? 1.5 and 1 2/3, 1 1/3 and 1.5. Yeah, what I could do, right, if I was going to do this, because none of those overlap or anything, and okay, that this answer, log base 2 of 3, if we can roughly work out what it is, we can pick the right one, yeah? Now, what is this actually saying? It's saying what do you need to do 2 to the power of to get to 3, yeah? Now, it's not obvious, it really isn't. I'd say, let me think. I'd say if you were doing 2 to the 1.5, if you like, well, that's actually going to be greater than 3, yeah? And therefore, I'm thinking, is that going to be greater than 3, actually, 2 to the 1.5? Because that's going to be, here's one, and this is my own silly way of working it out. You might think this is a stupid way of doing it. That would be root 2 cubed, wouldn't it? Now, I actually know what root 2 is a decimal. It's 1.414. Yeah, and root 2 times root 2 is 2, so we're actually going to do 2 times 1.414, and that equals 2.828. Yeah, cool. Right, okay, so here's my reasoning. I think I've worked out the answer now. Basically, I've ignored all of these facts. This is really quite dangerous, but because I can see each one of these answers, there's no overlap. So it's not really about what I can deduce from this. It's really about what does log base 2 of 3 equal. Is it between these two, these two, these two, or these two, yeah? Well, I think I can work that out using other methods, because I'm thinking basically log base 2 of 3 saying what you need to put 2 to the power of to get to 3, and I think it's probably about 1.5, because 2 squared is 4, yeah, and 2 to the power of 1 is 2. It doesn't work that it's just immediately in the middle though, but it's not a bad way to kind of have a rough guess, yeah. So I thought 2 to the power of 3 over 2, because maybe we need to put it to the power of 1.5, or 3 over 2, or 1.5. Well, 2 to the power of 3 over 2 is the same as the square root of 2 cubed, and as I know the square root of 2, this is, yeah, can I just show you a little bit more of my working? This is the same as root 2 times by root 2 times by root 2. I know root 2 is 1.414. It's a very famous result. Really helps if you know the odd decimal. Times by 2. So that's 2.828, yeah? Roughly speaking. But it's pretty close. I reckon it's correct to 3 decimal places. Yeah? Okay, so now I've got that, what I can say is 3 over 2, 1.5, isn't big enough to get to 3, and so I need it to be bigger than 1.5, but only just, because it's very, very close. So I would have gone B on that one, purely on that thing there. And I suppose you could work out what 2 to the power of 5 over 3 is, yeah? That's a bit more difficult to do. I probably should have used their facts, but it just seems obvious to me now that it's going to be there. I'll check it at the end and see if I'm wrong. Remember, you're in time conditions with these questions, so this is, I suppose, much more like what you'd be facing. Okay, right. How many regions of the plane do the following equations divide the plane up into when the three parabolas are drawn? Okay, y equals x squared is easy enough to draw. And in fact, all of these are easy enough to draw. Yeah. This is the same as y equals x times x minus 2. Yeah. So it's going to go through 0. And it's going to go through 2. The one thing you might say is, how do we know that these two don't meet here and here? Yeah. Well, let's see if they do. Right, x squared equals x squared minus 2x. In which case the x squareds cancel and you get 0 equals minus 2x, in which case you get x equals 0. So they only meet once at x equals 0. That's interesting, yeah? Okay, last one to draw on the diagram. X squared plus 2x plus 2. Well, that doesn't factorise, I don't think. It doesn't feel like it factorises. So let's have x plus 1. If it doesn't factorise, best to complete the square, isn't it? That'll give you x squared plus 2x. And then I'll need to take off the 1 and add 2, so that's going to be the same as plus 1. So this is obviously going through minus 1, 1. Yeah. Now, where does this hit the other two? Well, we don't have to know where it hits it. I really want to know if I can just label these A, B, C, and then label my diagram A, B, C. I really want to know with this curve C, I can see it's going to hit A there. I can see it must hit B there. Yeah. But I wonder if it hits many more than that. And the answer is no, it doesn't. Because when you set C equal to, for example, B, you're going to find that the x squareds cancel and you're left with a linear equation which only has one solution. And its solution is where B meets C, which is, looking at my diagram, here. Yeah? Yeah. So, you know, what was that answer? Look, let's have a look. 4x is minus 2. So x is minus a half. In other words, you know that that hits at minus a half, yeah? But it only hits at once, mine. So C doesn't meet B again. Now, does C meet A again? Well, once again, let x squared equal x squared plus 2x plus 2. And you're going to be left with a linear equation which only has x equals minus 1 as a solution. So that's at x equals minus 1, and that's at x equals minus a half. But note there were no other solutions, so we know that C isn't going to hit A and B anymore. Okay, right, now we just need to count the regions. Let's try and make the diagram nice and clear for this. So, careful counting. We've got 1, 2, yeah, because these curves go on forever. 3, that's all of that bit. 4, 5, this is all of 1, remember. 6, 7, and I don't think there's any I've missed, and so the answer is D. 7. And that's it. That's these ones done. Sorry about my answer as well to I there. I think it was a bit of a cheeky way of doing it. I quite like it though. Sometimes it's good to just use your own kind of like ways of doing things. There's nothing wrong with that. But yeah, maybe, ask me again if you're in my class and you want to challenge me on how that should be done properly. Ask me in class and I'll try and figure it out. Okay, all the best and well done. Bye bye.